Hey, this is Nicholas, and in this video, we're going to continue discussing the stack module. In the previous videos, I showed you how you can use the stack module to layer MIDI processors to create a sequencer. We layered Euclid modules and created a sequencer. And in another video, we took a multi-tap delay effect, which had 7 lanes, and we embedded the whole thing in a stack module. And in this video, we're going to use it to create synth layers. And this is the preset we're going to look at. I'm going to break it down how it works. It's a factory preset that I'm working on. And this is what it sounds like. And at a high level, the preset looks quite simple, but you can look at each stack layer and there's more going on. And the key module that's used throughout is a FM operator. And I'm assuming you have some basic understanding of how FM synthesis works, but I'll show you how FM operators work in Mela. So let's create another lane, and I'll insert an amp envelope first, and in front of it, I'll insert FM operator. And if I play a note, we're just hearing a sinusoid. Most oscillators in Mela add their output to the input. So that way, when you have multiple oscillators in series, the resulting sound is the sum of all the oscillator outputs. But FM operator works slightly differently. It takes its input and it modulates its internal sinusoid. And since this operator is receiving silence, that's why we're hearing a pure sinusoid. It's not being modulated. Now, if I duplicate this and play sound again, it sounds much richer, because what's happening is the second operator's sinusoid is being modulated by the output of the first operator. And we can adjust intensity dial and see how the sound changes. A sinusoid can also self-modulate. With a feedback parameter, we can set the amount of self-modulation. At the moment, both operators are playing the sinusoid at the same frequency, but things get more interesting if operators are playing sinusoids at different frequencies. And for that, we can use a pitch processor module. And specifically, pitch ratio is great for this because it lets us create an integer ratio between the operator frequencies. And here, the frequency is being multiplied by 3/2, effectively making the ratio 2/3. And this is what it sounds like. And you can adjust this numerator and denominator to get different results. That's basically it. So let's get back to our preset. The main thing you will notice here is that we have 2 stack modules. And first stack module contains 2 operators, and the second stack module also contains 2 operators. And what I'm going to do is I'm going to bypass this section here so we can hear just the first stack. And this is what it sounds like. And basically what's happening is that we get the MIDI signal in, gets converted to poly, and then this stack module has oscillators generating sound, and then amp envelope shapes that sound, and vel to amp makes it velocity sensitive. So let's look at each individual stack item. So OP1 is operator 1, where we have a FM operator, and it's basically a self-feedback. Intensity doesn't matter because input is silence, and it's panned left slightly, and it's also detuned slightly. Operator 2 is pretty much the same, but it's panned the opposite way and detuned the opposite way. And the third layer, it gives us a noise. It's a pitched noise and has its own amp envelope to give us that click sound. And we can hear them individually. So let's look at the stack view, and I'll collapse all the stack items. And let's bypass stack 2 and 3, and here the operator 1. This is operator 2. And this is our click sound. Now, output of this is then fed into the second stack module. And let's look at the third stack item first. What it does, it simply passes through the original signal. So operator 3 and operator 4, they take the input signal and they modulate their FM operators. So let's look at the operator 3 layer in detail. What's happening here is that main thing is this FM operator 3, and its pitch is an octave higher thanks to pitch ratio here. And then we have its intensity modulated using this LFO. And this LFO also modulates the relative pitch. So it's detuning, but the amount of detuning changes. And then it's also velocity sensitive because it's modulating its level here. And we can hear what this sounds like if we bypass other layers. Okay, so let's bypass this now and turn on the operator 4. It's similar to operator 3. And again, we have operator 4 here, which takes the same input, the input being the output of the stack 1. But its pitch is 3 times of stack 1. Again, it's modulated using another instance of an LFO, but this time the feedback is modulated here, and the rate of this LFO is slightly different from the other to keep things interesting, and it's also modulating the detune amount. And finally, we have another instance of Vel2 amp. So again, it's velocity sensitive. And we can hear what this sounds like. Okay, let's turn them all back on. And this is what it sounds like. As you can see, you can easily create synth layers with the stack module. Remember, there is also a layer module which lets you create synth layers, but with a stack module, you have slightly more flexibility. And if you combine stack modules with FM operators, you can pretty much create any classic FM algorithm. Okay, that's all for now. If you have any questions, leave a comment below. See you next time.